This is a presentation about dimension theory. Now, something that involves a length, like a straight line, is one-dimensional, but something that involves an area, like a rectangle, that's calculated from a length multiplied by another length, so that's two-dimensional. And then something like a cuboid, which has a length multiplied by a length multiplied by another length, is three-dimensional. So anything with volume is three-dimensional. And we get the 3 from the number of lengths that we have to multiply together. Length times length times length. So you can look at the formulas for things and tell whether they involve lengths, areas, or volumes. For example, pi r squared is a very famous formula. Pi times r times r. Now, r is a length because it's how long the radius of a circle is. So that's dimension 1. Again, multiplying by r, so we're multiplying by a length. So we've got a length times a length, dimension 1 times dimension 1. Pi, on the other hand, is just a number, 3.14159, so on. It doesn't represent the length of anything. So we've got a regular number times a length, and then a length times a length makes the whole thing dimension 2, and dimension 2 is an area. So multiplying two lengths together makes the dimension go up. And we know that pi r squared is the formula for the area of a circle. So here's an exam question. X, Y, and Z are all lengths. What do these formulas represent? So the first one, it's a length plus another length. That could be how tall you are plus how tall somebody else is. And that would give you how tall you are in total. So a length plus another length just gives you a bigger length. It doesn't make the dimension go up. But question B, you've got a length times a length. So that could be the two sides of a rectangle, giving you the area. So multiplying makes the dimension go up. Third one, length times a length. So the top is dimension 2. But then you're dividing by a length, which makes the dimension go down again. So the dimension of the whole expression is 1, which makes it a length. And then finally, question D, the dimension of the top is 1. The dimension of the bottom is 1, because it's a length plus another length. So the overall dimension is 0, because dividing makes the dimension go down. So the last expression represents none of those things, not a length or an area or a volume.